Welcome back to Think in Bits. This is the channel where we explore AI, software development, programming, and real-world coding experiments. In the next few minutes, I'm going to walk you through exactly what I built, why I built it that way, and how each part of the application works. This is a step-by-step explanation of the task flow project, from the first instruction all the way to a running product. Let us begin with the brief. I received a challenge prompt that asked for a complete, production-quality web application. The rules were strict. I was not allowed to ask clarifying questions. I had to make every technical decision myself. If something broke, I had to debug it and keep going until the app worked. The goal was a modern task management application with a long list of required features. Create tasks, edit tasks, delete tasks, mark tasks as completed, categories, priority levels, search, filters, responsive design, dark mode, local persistence, keyboard shortcuts, beautiful animations, empty states, loading states, and solid error handling. The user interface also had to feel like a real SaaS product, not a prototype with placeholder styling. That is the mission I executed. Step 1. Understanding the problem and choosing an architecture. Before writing any code, I decided what kind of product this needed to be. A task manager does not require a server for the first version if all data can live in the browser. So, I chose a single-page application approach. That keeps the experience fast, removes back-end complexity, and still satisfies every requirement in the brief. I chose React with TypeScript for the interface and type safety. I chose Vite because it gives a fast development server and a clean production build. I chose Tailwind CSS for consistent spacing, color, and responsive layout. I chose Zoostand for state management because it is lightweight and supports persistence middleware. I chose Framer Motion for intentional motion, not decorative noise, and I chose Lucide for crisp icons. The product name became TaskFlow. The visual direction was deliberate. Soft fog backgrounds, jade accents, warm ink text, and refined typography using Figtree for the interface and Francis for the brand. Light mode is the default. Dark mode is fully supported and remembered. Step 2. Project scaffolding. The workspace was nearly empty, so I created the application from scratch. I generated a Vite React TypeScript project, moved it into the workspace root, and installed the core dependencies. Then I added Tailwind through the Vite plugin, plus Zoostand, Framer Motion, Lucide React, Date FNs, and CLSX. After that, I configured the foundation files. I updated the Vite config to use React and Tailwind. I rewrote the HTML shell with the TaskFlow title, meta description, and Google Fonts. I created a custom favicon with a checkmark on a jade background, and I replaced the default style sheet with a full design system using CSS variables for light and dark themes, background atmosphere gradients, focus styles, and font utilities. At this point, the empty shell was ready for real product code. Step 3. Defining the domain model. I created a clear TypeScript model for the application. A task has an ID, title, description, completed flag, priority, optional category, timestamps for created and updated dates, and an optional due date. Priority has 4 levels: low, medium, high, and urgent. Categories have an ID, name, and color. Filters cover status, priority, category, and search text. Sorting options include last updated, newest created, priority, and title. I also defined shared constants, default categories for work, personal, health, and learning, priority labels and visual styles, storage keys for local persistence, and a documented list of keyboard shortcuts. Utility helpers came next: a class name merger, a unique ID generator, search matching, priority ranking, and a pure function that filters and sorts tasks. That pure function became important later. because it keeps filtering logic reusable and prevents React state loops. Step 4. Building the state layer. The heart of task flow is the ZooStand store. This store owns tasks, categories, filters, sort order, hydration status, and error messages. From the store, the app can add a task, update a task, delete a task, toggle completion, set filters, change sort order, add a category, delete a category, and clear completed tasks. When a category is deleted, related tasks are unassigned instead of breaking. When a title is empty, the store raises a clear error instead of saving invalid data. Persistence is handled through ZooStand Persist middleware. Tasks, categories, filters, and sort preferences are written to local storage automatically. Theme preference lives in a separate theme store. When the page reloads, task flow restores the previous state so the user does not lose work. I also built a hydration hook. On first load, the app waits until persisted data is ready. There is a short loading screen with a subtle animation. If storage is blocked or slow, a safety timeout still lets the app continue. Theme class names are applied to the document root so dark mode does not flash incorrectly. Step 5. Creating reusable interface components. I built a component library before assembling the full screens. That kept the code clean and consistent. There is a button component with primary, secondary, ghost, and danger variants. There is an input and text area with labels and validation messaging. There is a select with accessible labeling. There is a modal with backdrop blur, escape to close behavior, and spring animation. There is a badge for priorities and categories. There is a checkbox with a satisfying animated checkmark. There is a toast system for success and error feedback. There is a theme toggle. There is a search bar with clear action. And there is a shortcuts help panel. Later, I also added an error boundary. If something unexpected crashes the React tree, the user sees a calm recovery screen with a reload action instead of a blank page. Step 6. Building the task experience. The task form supports both create and edit modes. Users can set a title, description, priority, category, and due date. Title validation is immediate. Cancel and submit actions are clear. On success, a toast confirms the change and the modal closes. The task item is the main workhorse of the list. It shows the checkbox, title, description, priority badge, category badge, and due date. Overdue dates are highlighted. Hover and focus reveal edit and delete actions. Completing a task strikes through the title and softens the card. Animations handle enter and exit so the list feels alive without becoming distracting. The task list separates active and completed work. If there are no tasks at all, the empty state invites the user to create the first one. If filters hide everything, a different empty state explains that no matches were found and offers a clear filters action. The task filters component provides status tabs for all, active, and done. It also provides drop-downs for priority, category, and sort order. Combined with search, this makes large task lists easy to navigate. Category management lives in its own modal. Users can add named categories with color presets, review the existing list, and delete categories they no longer need. Step 7. Designing the application shell. The layout is split into a sidebar and a main content column. On desktop, the sidebar stays visible. It shows the task flow brand, a primary new task button, overview counts for all, active and completed tasks, a category list, category management, shortcut help, clear completed, and the theme toggle. On mobile, the sidebar becomes a slide-over drawer opened from the header menu button. The header itself is sticky. It shows the page title, live counts, search, and a quick Create button. The main column centers the filters and task list at a comfortable reading width. This structure makes task flow feel like a real productivity product. One clear workspace, strong brand presence, fast actions, no cluttered dashboard noise. Step 8. Adding keyboard shortcuts and motion. Keyboard shortcuts are a major productivity layer. Press N to open a new task. Press / to focus search. Press D to toggle dark mode. Press question mark to open the shortcut guide. Press Escape to close a dialog. Close the mobile menu, or clear the current search. The shortcut system is careful. It ignores key presses while the user is typing in inputs, text areas, or selects. That prevents accidental actions during editing. Motion is intentional throughout the experience. Modals rise in with spring physics. Task cards animate into place. Completed items leave smoothly. The loading mark pulses gently. The toast slides up from the bottom. These details make the product feel polished and trustworthy. Step 9. Handling edge cases and quality. I treated edge cases as part of the product, not afterthoughts. Empty states guide first-time users. Loading states cover hydration. Form validation blocks empty titles. Delete confirmation prevents accidental loss. Toasts communicate success and failure. Overdue dates are visually distinct. Completed tasks remain visible but quieter. Clearing completed tasks is available only when there is something to clear. Filters can be reset in one action. Local persistence survives refresh. Theme preference survives refresh. And the error boundary covers unexpected runtime failures. I also fixed real bugs during development. One serious issue was an infinite render loop in the sidebar. The store selector was calling a function that returned a new object on every read. React treated every render as a state change and looped forever. I fixed that by deriving stats with memoization from the tasks array. I also extracted filter and sort logic into a pure helper so the main view could compute filtered tasks safely. Another issue appeared when restarting the development server. Older Vite processes were still occupying ports, so I cleaned them up and relaunched cleanly on port 5173. Step 10. Verification and delivery. Once the features were in place, I ran a production TypeScript build. The build passed. Then I started the Vite development server and confirmed the app was reachable. The final application is called TaskFlow, and it runs locally in the browser. Here is what a user can do today. Open TaskFlow. Create a task with a title and optional details. Assign a priority. Attach a category. Set a due date. Search across titles and descriptions. Filter by status, priority, or category. Sort the list. Complete tasks with one click. Edit anything later. Delete with confirmation. Manage categories. Switch to dark mode. Use keyboard shortcuts. Refresh the page and find everything still there. That is the complete journey. To summarize one more time, I took an open-ended product brief, chose a modern front-end stack, designed a calm SAS visual language, modeled the domain carefully, built a persistent state layer, assembled reusable components, delivered a responsive task workspace, added shortcuts and animation, handled empty loading and error states, fixed runtime issues, and shipped a working application. TaskFlow is ready to use. Open localhost on port 5173, create your first task, and start flowing. Thanks for watching. If you enjoyed this experiment, make sure to leave a like and subscribe to Thinkin' Bits for more AI coding challenges, development experiments, programming tutorials, and honest reviews of the latest developer tools. Have an idea for the next challenge? Leave it in the comments. I read every suggestion. If you'd like to test your own programming skills, check out thinkinbits.com, where you'll find free coding challenges designed to help you improve through real problem solving.